All right. Welcome, everybody, to this semester's final AI ethics seminar. Uh, our speaker today is Moa Johansson from Chalmers, who will be speaking about setting the AI agenda, evidence from Sweden. And without further ado, I hand over to you, Moa.
Thank you. I will start showing my slides first of all. There you go. This should...
Looks good.
Yeah. Right. So thank you all for being here the week before Christmas. So I'm going to talk about some joint work that we have done in project funded by WASP HS. So this involves a lot of people here on the slide: Bastian Brunsma, who was a postdoc here in Chalmers, Annika Fredén from Lund University, myself, Kajsa Hansson, also a postdoc at Lund University, Pasco Kisic-Merino from Karlstad University, and Denitsa Sainova, also of Chalmers. So this work was recently presented at the A-Equitas workshop, which was co-located with ICAI in Spain just, I think, a month ago. Right. So see, there we go. So no one has missed that ChatGPT was released just over 2 years ago now. And back then, it feels like a long time ago, but many people were very surprised on how well this system could produce language. I mean, previous chatbots had struggled to make coherent answers or become rude and insulting and quickly been taken down by their authors. But this was something a lot better. And naturally, there was a huge media interest, both by traditional news media and by social media and so on. So all of a sudden, the general public also realized that AI was a thing. It was not just something that existed in a few dusty university corridors or in science fiction novels, but this was actually something they could play with and use. So even some people found it quite unbelievable that a machine could produce language at such a level of fluency without being genuinely conscious. So it was very easy to anthropomorphize ChatGPT. So this happened even to an unfortunate Google engineer who sadly got sacked after having become convinced that the chatbot he was working on, it was a language model called Lambda, was in fact conscious. So we all had to kind of revise our views and accept that what we previously thought was a uniquely human skill was in fact also possible to automate via statistical processes. So, of course, there was a lot of talk. What are now the risks and opportunities? We got these new fancy AI systems. It seemed to be few limits of what they could do. So what we were interested in our group was to study a little bit, okay, this whole debate now going through the roof, but politicians appeared to be absent, and maybe it was more academics talking about AI, which surprised our political science colleagues somewhat, because again, agenda setting in Sweden has traditionally been done from the top down. So from politicians acting in a few specific Swedish media outlets. So, for instance, DN, Dagens Nyheter, their debate pages is usually where politicians tend to go to test their new ideas, but that wasn't quite the case. So we set about to study who actually was setting the agenda in this initial 2 years after years after the release of ChatGPT and before. But before I dive into this study, I wanted to give a brief primer about LLMs, just to make sure. I don't know I don't know all of you in the audience, and just to make sure that we all have a little bit of a common understanding of how these large language models work. So ChatGPT is a particularly large language model. And what makes it so impressive? Well, one of the things that happened in the year before ChatGPT was that there was a new type of neural network architecture that was developed. It's called a transformer. And the transformer is, the great thing with the transformer is that it is very scalable and parallelizable. So it gets better the more compute you give it and the more data you give it. The previous architectures have maybe scaled up to a point, but then sort of hit a ceiling, whereas these transformers seem that you could scale them more and more and more, and they got better. Also, one of the important features is that they used something called attention, and that's a way of for the neural network to learn which part of the input text is most relevant when you're going to produce the next output word. So the first step when you train this kind of large language model is to train it on something called to do autoregression. And that basically just means that you're going to train the model to predict the next word in a text, given some text you've seen so far. So this is very easy for us to do as humans. So I have two examples there. For instance, Chalmers University of, well, probably should come technology after there. And if we produced a bit more text, Chalmers University of Technology is located in, well, then we will probably say Gothenburg, hopefully. So this is it. This is autoregression. And you can imagine doing this, not just on two examples here, but on something along the size of the internet. So this is easy. You know what should come there because you have the text, and you can then tell the model whether it was right or wrong, and it can update its weights. Okay, so that's the first step. So after we've done autoregression, we have a model that's very good at producing the next token or the next word. But if we want to ask questions and have a dialogue, we need some more ingredients. So, for instance, if you have trained a model to do this autoregressive task, predicting the next word, you are in fact not very likely to get a good answer if you type in a question. And why is this? Well, on the internet, it's actually quite unlikely that a question is followed immediately by the correct answer. It might be someone typing on a chat forum asking a question and then asking another question and writing some more text, and the answer is somewhere further down. So we needed two more ingredients, and this was, I think, probably one of the key realizations of OpenAI, that it realized that people actually they don't want to do autoregression, they don't want to do autocomplete, they want to ask questions and have dialogues. So they started collecting a lot of questions from people, which got them ahead in this chatbot race. So the first thing I want to mention here is something called instruction fine-tuning. And instead of just carrying out predicting the next word, you train the neural network a bit more to, for instance, answer questions or translating a text, taking instructions. So you need to collect commonly occurring questions and commonly occurring instructions, and for that you typically need humans. But there's one more step. There's something called reinforcement learning with human feedback, or RLHF for short. So that's also very important to train the model to assess what is a good answer to a particular question, what is a bad answer, and also to get rid of toxic text. So remember, this is trained on the whole internet. And as you probably know, there is a lot of not so nice content on the internet, and that's all gone into the training data. So we need some way of then getting rid of that. And that's what RLHF is for. You don't get rid of it 100%, but you can at least make it less toxic. So for doing these steps, we need a lot of data from humans. So we need to hire people to do this. And this is preferably done cheaply in countries where you not have such high salaries, similar to how social media networks do content moderations and so on. But anyway, now we have a fine chatbot that can take instructions, answer questions, and isn't too offensive. And we can release it and wait for the headline, which is what OpenAI did 2 years ago. So the debate takes off. Right, now back to our study. So anecdotally, we observed that there's a lot of debate going on now about these new AI systems, about risks and so on. So let's see what's happened. And this is kind of a pilot study. So we started in Sweden because this is where we are, and we could easily get debate articles from the media archives. So we collected them from the years 2016, so way before we had ChatGPT, up until 2023, end of 2023. From the newspapers you see listed there on the slide. So these are kind of the major ones in Sweden, national newspapers. This was only 74 articles in total. So this was kind of such a small data set. So we decided that this is probably something we should just look at by hand. And we were particularly interested in categorizing the core argumentation. So whether or not these articles were talking about AI risks. So there was, anecdotally, at least to us, there was a lot of talk about risks. So we roughly wanted to give at least a rough estimate of what kind of risks people were talking about. So we had 3 native speaking researchers who then tried to roughly categorize these into 3 categories. Again, this is something we might revise slightly for a larger study, but this was what we did for this pilot. So not about risk at all, or something that's about immediate or short-term risks, so concrete risks about current AI systems and how they're deployed and implemented and so on. And the third category about more hypothetical risks or very long-term risks. So related to hypothetical future AI systems, for instance, existential risks and of artificial general intelligence, or something at least that we don't have right now. Of course, I know that the term short-term and long-term is, of course, arguable. What's short and long-term? So in some of these debate articles, especially in the first few months of the ChatGPT release, people were claiming that AGI was more or less imminent within a few years or months, but as it is not now. So maybe you want to think of it as immediate and hypothetical risks instead, if you prefer that. Okay, so let's look at an example. So here is kind of a typical debate article in this immediate or short-term risk category. This one is, it says in Swedish here, of course, young people risks losing their first job to AI. And it's a reasonable concern. So considering, for instance, that large language models are quite good at automating things that require some intellectual work, but still have a fairly large routine component. So if we take, I'm a computer scientist, so for instance, coding assistants, like this one called Copilot, they are becoming fairly competent at writing standard boilerplate computer code in common programming languages such as Python, which would maybe previously have been written by some junior programmer, for instance. And also, you can imagine things like, I don't know, copywriting for advertising, or creating basic imagery for advertising, or whatever. Those kind of things that are maybe not a very large creative component. So you can see how that could be threatened by AI. Other issues here called, for instance, for more AI education, both in schools and universities and to the general public. Worries about the lack of transparency if we use neural networks for automation. So they are notoriously uninterpretable. Also concerns about the bias in the AI training data, and so on. So what we coded as hypothetical or long-term risk is, you might recognize this gentleman who's the author of this debate article here. Leading AI companies are playing Russian roulette with humanity. So this article argues that the very fast development will lead to AGI, so that stands for artificial general intelligence, which will very likely, or quite likely, or however likely, end humanity. So full disclosure, Ole and I don't quite agree on this, but just so you know. Other of these hypothetical or long-term risk concerned autonomous weapons. Well, we have already autonomous drones probably being used in current wars. So this is maybe doesn't quite fit in here, but here I think there was an article which took this a bit further and talked about humanoid robots being used in wars and so on. So. And there's also some articles that ended up in this category which speculated about the relationship between AI and religion, and AI and the church, and how people would consider that. Okay, so what do we find? No big surprises. So since the release of ChatGPT, that is the dashed line in this figure, there was quite a sharp increase. So you can see that all kinds of debate article, this is the cumulative count, so it has to go up. But the slope kind of changed drastically after the release of ChatGPT. And well, hopefully this has leveled off by now. Otherwise, Swedish newspaper articles would write about little else than AI. But this trend was still going strong throughout 2023. So who wrote? Was it the academics? By the way, if people are asking questions in the chat, I can see them, but I will take questions afterwards, I think, because I don't really see what you write in the chat. So who wrote? Well, we can see that there was in total, there was definitely our intuition that it was a debate driven by academics seemed to be true. So there's about almost half of these articles, there are only 74, so, they're not that many, but over 30 were in fact written by academic authors. Representatives from industry are about as common as political actors, and there's also a few NGOs represented as non-governmental organizations. And I think in there we have organizations like RISE, for instance, which is a research institute. I suppose they're kind of governmental. various agencies and so on. So yeah, another thing I should mention, so about risk. So definitely it also seemed to be the case that the academics wrote a lot about risks, particularly short-term risks, whereas politicians wrote about other things than AI risk. And similarly with industry people. So it seems to be the academics that were mostly concerned with AI risk here. Who wrote? So here we've tried to count a little bit by topic of these people. What did they write about? So are there any particular academic subjects that are more interested in different kinds of risk? So you should note here that these are the count in terms of in number of articles. So some authors might have been represented more than once in this data set. So one interesting observation is that the people writing about the long-term risks are generally not computer scientists. Well, it's one data scientist, I think, there, but generally they're not computer scientists. They're not. They appear to not be the people who are actually developing the technology and presumably have the highest technical expertise in there, but rather they are in mathematics and physics, for instance. So yeah, so there is a interesting observation here that perhaps there are a few individuals in other academic fields who are mostly interested in the long-term hypothetical risks. Okay, what about topics and categories, loosely speaking? So again, it was indeed the case that the questions about ethics, regulation, and risks were quite popular. So regulation probably comes up quite high because this was also the period when the EU AI Act was discussed. So there was quite a fair few articles criticizing various aspects of this proposed regulation. But there was a lot of discussion also about ethics in general, so risks associated with AI decision-making in moral dilemmas or in medical applications, and so on. So yeah, these categories are a bit blurred. They were what our coders came up with. So that was kind of the risk regulation ethics cluster there at the top. After that, we get some more another cluster of topics that concerns application characteristics, and then also how so applications connect also to topics of the economy and labor market. So how will AI transform the retail sector? How will the job market worsen for young people because of AI? What will be automated? What will be the jobs of the future? And what will definitely not be jobs of the future? And so on. Education and research, of course, topics that are discussed here, calling for more interdisciplinary research in AI, for instance. Fairly low interest in reasons such as sustainability, which is kind of interesting because I guess Sweden otherwise have been quite a green country, but not so much here in the AI debate, which I don't know if that's something that's come later after 2023 when you start discussing, for instance, the electricity that's needed for these data sets that are driving chatbots, for instance. A couple of people are very techno-optimistic, but we didn't see so much of that. So this in this category, you would have people saying that, yeah, we really need to accelerate AI because it's going to solve a lot of our societal problems, and we're all going to have to work less, and it's going to be a bright new future. So I'm going to summarize a little bit this study. I do have a few more slides, which I think I have time for. But yeah, to summarize, there was indeed an academic dominance in this debate, and there was a focus on short-term risks, which somehow surprised me because at the time it felt like there was in fact a lot of discussion about long-term risk, and internationally there was, I don't know if you remember this very famous pause letter that AI development should be paused for 6 months. But there was a few loud voices in Sweden advocating this, but not so many. On the other hand, there are yes. So on the other, there was definitely a clear peak of the short-term risk discussions after this ChatGPT. And interesting also is that among computer scientists, there didn't seem to be people worried about these long-term or hypothetical risks, in Sweden at least. And politicians were very silent about risks in general, presumably maybe because they wanted some more on their feet before starting making predictions. So they set up this AI commission, which recently returned a report. So it will be quite interesting to see if politicians become more vocal now after that report came out. This, what I told you about now, is in a paper with the same title as this talk, which you can find online. It's been published recently. And I can make a little bit of a break here. So my plan is that I will continue to talk a little bit about what's been happening in 2024, but that's not covered in this particular paper. So if anyone wants to ask some questions about this study, you can maybe do that now, and then I will continue. I see there are things written in the chat. So yeah.
I don't know, Johan, would you like to ask your question now, or is it better saved until the end when we've heard of 2024 as well? Perhaps it's best to say that to the final discussion.
Yep.
But if anyone else has a question about the paper, I think we can just go on.
Okay, I will just go on. So I will talk now a little bit about what's happened in 2024. And if you don't like what I say from now on, you shouldn't blame my co-authors. You should blame me. Right. So a lot of things, of course, happened after this study ended. So, for instance, the EU AI Act was passed, and it's now going to be implemented. So it's the kind of first big package of regulation of AI, and of course we can discuss the finer details and how incredibly hard it is to make this kind of regulation. So we had back in February we had a lawyer invited to Chalmers who gave a talk about this. But at least there are some good points, I think. So, for instance, they specify different areas of use, and if you are allowed to use, what kind of AI you are allowed to use for applications. So, for instance, social scoring is forbidden altogether, and then various other applications have different requirements of transparency and explainability and so on. So the other thing that happened, well, in the months after the release of ChatGPT and GPT-4, there was many articles and papers arguing that, wow, GPT-4 can pass the bar exam or pass other exams and do this and do that. And what happened was that a lot of these claims were being criticized, and people actually checked on these studies. So, for instance, in May this year, there was a study from MIT that nuanced its previous announcements from Stanford and saying, well, GPT-4 didn't ace the bar exam after all. So they criticized this original study and cited actually that was not a good study design. And they had compared chatbots with students taking a re-exam. So that was the weaker students. And they had focused too much on the multiple choice part and not compared answers on the essay questions, which are in fact more relevant and more similar to the task that a lawyer needs to do. So yeah, we started to get this. Another example, for instance, came from someone who works in planning, Kamba Pati, who tested whether LLMs could do well on planning tasks. They have a competition each year on planning. So these tasks, one of them was to play this board game called Labyrinth. I don't know if you are familiar with it, but basically you have loads of cards that make up a maze and you need to move through this maze. But the tricky thing is that your opponent keeps moving the cards, so the layout of the maze will dynamically change. So you get this kind of dynamic planning problem, which is quite hard. So they tested various large language models on this and concluded that nothing that I have read, verified, or done gives me any compelling reason to believe that LLMs do reasoning or planning as it's normally understood. So armed with a web-scale training, remember we trained it on the whole of the internet, it's a form of universal approximate retrieval, which can sometimes be mistaken for reasoning capabilities. So we're starting to nuance the performance of LLMs. Of course, these systems will improve, and OpenAI released recently a new system which does a bit better on reasoning through some fine-tuning or other methods. However, maybe what's worse for the development of LLM is the lack of internet. So maybe last week there was a big AI conference called NeurIPS, and one of the keynote speakers was Ilya Sutskever, formerly of OpenAI, and he was also pointing out that the era of pre-training is most likely over. We have hit the ceiling of scaling the data because we only have one internet. And there's been now during the autumn, there's been a few articles, you keep seeing them regularly, where people are starting to speculate, well, it seemed to be diminishing returns. There is no more exponential scaling of large language models. They don't get even larger because we've already trained on the whole of the internet. So we need to do something else now. So one of those things, something else, could be to develop more specialized models. And some of these gentlemen that won the Nobel Prize this year did exactly this. So the Nobel Prize in Chemistry went to among others, Demis Hassabis and John Jumper of Google DeepMind, who developed a system called AlphaFold that does exactly one task, but it does it very well, and that's calculating how proteins fold up from the DNA sequence, how they fold up and form a 3D structure. So AlphaFold is not just a big neural network. It's got a component which is a neural network. I think it's some sort of similar architecture to a transformer, but customized to their application. But it also brings in a lot of factual knowledge about chemistry and how these molecules behave. So some people have argued that AlphaFold is an example of something called a neurosymbolic system. So a system that both has a neural part and also a more conventional computer science symbolic part. That's the symbolic based on rules and database facts and so on. And of course, AI got another Nobel Prize in physics even before to some of the foundations. So the Hopfield network by John Hopfield, of course, and also Geoffrey Hinton, who's been quoted as been called one of the godfathers of AI, and he received, for instance, the Turing Award, which is in computer science, that's our equivalent of the Nobel Prize, together with Joshua Bengio and Jan LeCun, but this was a few years ago now. So, coming back to risks now, Geoffrey Hinton likes to talk about risks. So he gave a short but poignant speech during the banquet. And he started off saying that if the benefits of increased productivity can be shared equally, it will be a wonderful advance for humanity. I very much agree with him on that point. So indeed, we do need strong regulations. We need strong institutions. And all of us are not going to be benefited by having big monopolies of big tech companies. So we need AI to benefit all, not just a few tech billionaires. And this is also a topic that's been discussed in the economics prize. So there's a lot of connections here. Or not really for the economics prize by the economics prize winners. I will come back to that in a few slides. And then he continued, and towards the end of the talk, I stopped agreeing with him. So he said that, but now we have evidence that if they are created by companies motivated by short-term profits, our safety will not be top priority. We urgently need research on how to prevent these new beings from wanting to take control. They are no longer science fiction. So it was a very theatrical ending there. And now I'm thinking, well, hang on here now. New beings? What new beings are you talking about? Large language models? Well, that's kind of where we are, state of the art so far. If you're not talking about large language model, then, well, they kind of are science fiction because we don't have them yet. And if this not yet existent technology, which we know nothing about, it would apparently want to take control. Why? So this end seems it's not particularly well grounded. It's vague. It isn't actionable. What sort of research do we need to prevent some fictional new beings from taking control? So, well, how about we replace the new beings with unrestrained capitalism? Well, we have things like corporations, which act a bit like what he describes, but, well, that's not what he's talking about. Maybe he should worry a bit more about that. So, this argument that he's put forward in many talks, many other occasions, is that we won't see it coming. I don't we won't see this super intelligence coming. I don't think it holds. Just because, for instance, ChatGPT wasn't on the radar of the public before 2022. The research underpinning it has been going on for years, in fact, since 80s and so on, when they did their seminal work. So, for instance, and also, okay, Geoffrey Hinton, he's a big cheese in AI, but there's other big important people who don't agree with him at all. So his fellow godfather, Jan LeCun, for instance, doesn't agree. The third one kind of keeps balancing in the middle. So Jan LeCun has often said that, well, hang on, don't we have to first pass, for instance, cat level general intelligence before? So we will see a super intelligence coming. It will not be a surprise. And ChatGPT is a great language model, but it's still a model. Nowadays, no one is claiming that it's conscious, and it doesn't possess whatever intelligence allows cats to go about its daily business, navigating the world and so on. Okay. So I'm going to finish with a couple of slides arguing that these new beings are still science fiction. So exhibit 1, these nice colorful pictures comes from something called the ARC Challenge, which was designed by Francois Choulet, formerly of Google, where he led the development of the Keras machine learning framework. And he has written a paper called On the Measure of Intelligence, where he argues that just evaluating AI systems on various tasks doesn't in fact test general skill acquisition abilities, which we humans can do. So humans can only acquire skills by such a general skill acquisition ability, not by being exposed to all the data on the internet. So he's in fact saying in his paper that there is no task X such that skill at X demonstrates intelligence unless X is actually a meta task involving skill acquisition across a broad range of tasks. And he wrote this, by the way, in 2019, so that was before ChatGPT. So here is some example from this ARC challenge. So there you have a bunch of images. So you have 3 examples, and then you have a 4th one, which is a test where you're supposed to figure out what should go there in place of the question mark. And this is pretty easy for humans. So I think that most of you in the audience probably have figured out what the trick is. So on the left-hand side, we should zoom in on the plus for the question mark, because the pictures there that are zoomed in easy to figure out, but it's very hard for AI systems. Currently, the best performance on this ARC challenge, I believe, still is by symbolic program synthesis. There's a big cash reward now, so if someone is up for a challenge, you should try to develop something for this. I should also say that the test set for this ARC challenge is, of course, not on the internet, so we don't want any data leakage from the evaluation. So I'm running out of time. So just quickly, the last couple of slides. Another mention from NeurIPS 2024. Again, this huge, big AI conference that was finished last week, where Joshua Tenenbaum, a cognitive scientist at MIT, who worked a lot on AI, he gave a talk where he was contrasting today's AI system with that of human minds. And in particular, he emphasized similar things to Francois Chollet, that intelligence is what enables us to learn efficiently, not something that's the end result of staring at huge amounts of data and looking at the entire internet. And similarly, generalization in humans depend on creating mental models of the world, not interpolation from training data. So again, this relates to this topic of diminishing returns of scaling. We are running out of human-produced text, but we still don't have language models that are as smart as we are. So how about human children? So this was another keynote at NeurIPS by Alison Gopnik. This is a paper of hers. It goes along the same theme. So Alison Gopnik is a developmental psychologist. She studies child development. And she argues that AI models should be viewed as cultural technologies. So it's something that enhances transmission of information, and it should be compared to, for instance, print, the internet, etc. And other technologies that allow us humans to share information effectively and to learn by imitation. So Gopnik studies what skills can be transmitted through this kind of imitation learning, because human children do that, like LLMs do that too. But she also studies what requires genuine invention. So children do both. They do both imitation learning and genuine invention. However, LLMs tend to fail on the kind of innovation task that even very small children can do. So for instance, tool innovation, making a new tool for a task or using an existing one in a novel way. I think one of the examples they have in this paper was how to draw a circle. Which object could help you draw a circle? Well, is it a ruler, or you didn't have one of these specific tools for you put a pen in and you draw a circle, but you had a teapot. And for the children, it was quite easier to figure out that, well, the teapot, you can draw around the bottom of it and you get a circle. But for the language models, this was challenging. Okay, I want to finish by saying something about what I think are more interesting questions related to AI risk and AI development and what we want AI to do. So I don't know, maybe some of you were also at Simon Johnson's Nobel lecture this past Saturday here in Gothenburg. And he was talking a lot about what impact AI will have on jobs and incomes and the labor market and the economy. Will it mean that no one has to work? So this very techno-optimistic view that's popular in the US, maybe not so popular in Sweden as we saw. Or will it lead to mass unemployment by automation? So will it get jobs away without replacing them with new tasks, or will there be new tasks? What sort of so Johnson was saying that we need to have pro-worker AI, so something that makes us all more productive and creates new tasks. But maybe that won't happen if we just have AI that automates away tasks and doesn't replace them with anything meaningful. So that's an interesting question. Will if there are new tasks, will they be fairly paid, or will it just be big tech making even more money, Elon Musk becoming even richer, and so on? And finally, just tying back to this existential risk and long-term and short-term risks. So I think one of my colleagues, we had a discussion of this, and he said, well, they're cheap risks and expensive risks. So existential risks, they're kind of cheap to fix for the companies. They hire some philosophers, and they say we're working on AI alignment, and we are the ones to fix this. Don't you worry. Yeah, we can maybe have some regulation, but to make it hard for those upcoming startups. And we are the ones who can control AI, and we work in alignment. Don't worry. On the other hand, it would be very expensive. There are expensive risks as well. And the expensive risks are maybe these more immediate things. So if, for instance, we stopped considered using copyrighted material for training LLMs as falling under fair use, this would be a bit disaster for big tech. If they would have to pay for all their training data, this would be very expensive and decrease shareholder profits. So I think on that note of cheap and expensive risk, I will stop. Thank you very much for listening.
Thank you very much. Let's have a round of applause for Moa. And let's see, I'm going to open the floor for discussion, but we have already in the chat a question from Johan Falk. Would you like Johan to grab the phone and ask it? And Moa, if you take down the slides, we can all see each other a bit better.
There we go.
Thank you.
Thank you for this presentation. Also, just this opportunity for discussion, which I think is very valuable. I think you discussed the expertise in Sweden, the computer scientists not being as concerned with the long-term risks as some other parties. I would say that the computer scientists in Sweden don't really work with this kind of AI. Very few people in the world do. So I'm not sure that the Swedish computer scientists actually are more experts in this than, say, physicists or someone else who does a lot of reading and following these matters. What do you say about that?
Well, first of all, I think that's not entirely true. I mean, I think there are certainly computer scientists that use and train and fine-tune large language models and look into mechanistic interpretability on how they work when they answer queries and so on. There's certainly many people in my universities that work on that. There's AI Sweden that trained a GPT-3 model on the Swedish language, for instance, not too long ago. So I don't think that's true. I don't think that's entirely true. So, I mean, it's a question of scale. Maybe we don't work on GPT-4, but we work on similar models at a smaller scale. And there's certainly many similarities between those models and the larger ones. So I think you are I think it's actually
okay,
a bit
let me try to clarify.
Computer scientists don't understand it any better than
okay. So
mathematicians.
I admit being partly wrong, but I'd like a chance to clarify. I think one very important question when it comes to understanding the AI progress we see today is the pace of progress. And I believe that pace of progress is best understood at the front line, which is a few companies in the world that is directly experiences this front line. Would you agree? No. Okay.
Not entirely. I mean, I do think other people, computer scientists and people working in AI will understand this sufficiently. So
okay.
Not sure. I mean, of course, they have their company secrets that they don't put out in papers and so on. Non-disclosure agreements and so on. But I've not just been quoting researchers in Sweden. I've been quoting researchers giving invited talks at the NeurIPS conference, which is the premier venue for AI in the world. It's got like 15 to 20,000 people attending. I would think at least these people know what they're talking about.
Yeah. I agree. We perhaps should let someone else talk also, but I think there are, as you also mentioned in the presentations, some big experts that are concerned about the long-term risks with AI.
Yes, I mentioned Jeffrey Hinton.
Yeah, and there are at least two of the big AI companies are explicitly worried about the catastrophic risks from AI.
Yes, and I'm also, I wonder if that's so I challenged that a little bit also. So I said that, is this a genuine concern, or is it a way of distracting from other risks that would be more expensive for them to address? So if you're a big tech company, you do not, for instance, want to not be allowed to use the internet for training. What if you have to pay for all that copyrighted material? That would be incredibly expensive if it was to no longer be considered fair use. And there are a number of lawsuits going on now, OpenAI versus the New York Times, for instance, and so on. And there's been, for instance, voice actors that's been very upset that their voices has been used to train AI systems. And so, yeah.
I think you've given a good answer to my question, so
yeah.
I'm happy. Thank you very much.
So now I see a bunch of statements in the chat, but no actual questions. So if someone does have a question for Moa, then you can just grab the microphone and speak up. We have a few more minutes. Well, if not, then let me take the opportunity to ask one question. Speaking on this about this NeurIPS conference, you quoted Ilya Sutskever, and you mentioned his talk about running out of data. But you stopped there and didn't mention how he nevertheless expects us to go on towards superintelligent AI.
I can talk about that if you want.
Yeah, please.
I have some notes on that. So what he was saying, that this is the end of pre-training, and what he saw as the next step was to, for once, creating agents, having agentic AI, and also to add reasoning to these systems. So there he said that having reasoning, and here I don't agree with him, would make the models more unpredictable, because chess bots sometimes, I think he exemplified it with the chess bot, they're sometimes making moves that are unpredictable to players. I'm not sure I agree there. If they do reasoning and logical reasoning, then it should in fact make them more interpretable. Reasoning is closely related to topics such as verification. Similarly, if we have agents, AI agents, there are techniques. We had a lecture in our course, in fact, only today, by a colleague who talked about how you have something called monitors on autonomous systems. So his example was an autonomous vehicle, which might have a neural controller for driving, but under certain conditions where we don't trust the neural controller. So for instance, if the lighting conditions are bad, or if it's raining, this monitor will go in and say, okay, now we're disconnecting the monitor. So there are certainly many techniques in existence already today which applies to these directions that he pointed out. I think he also said, which was funny, that I'm not saying how, I'm not saying when, and it's impossible to predict the future at the end of his talk.
Yeah. Do you disagree with that?
No.
No.
I mean, of course, it's we can only speculate about the future. From a more or less informed viewpoint of where we are today. So yeah.
Yeah, very good. I think that's a good note to end on. So thank you everyone for joining. Thank you so much, Moa, for the talk. Thank you, those of you who contributed to the discussion.
Thank you very much.